Hi guys, welcome to my ninth episode of Love the Byte series. My name is Samuel Kamochu, a telecoms and a software engineer. I'm also the co-founder and the lead paysetter at Meliora. In this episode, my objective is to help you appreciate data types and probably a new concept, big and little endian. So what's a byte? I think we covered a byte in the previous episode where we said a byte is the smallest addressable unit in memory and comprises of 8 bits. We know that 8 bits give us 256 possible values or patterns. And when all the bits are set to 0, we get a 0. When all the bits are set to 1, we get 255. And this is in decimal format. You must agree with me that this range of values is not sufficient to cater for all the world problems. Sometimes you might need to store data that is more than 255 or even less than 0. So, and this calls for what we call the data types. And these data types at times can store data in more than 1 byte. So you have probably seen int, char, float, enum. All these are data types. So we are not dealing with that foreign or new concept to most of it. A data type in my own definition is an abstraction, meaning that you don't have to worry about the details, that allows us to simply declare variables easily without worrying about how they are represented in bytes or bits in memory. So in Java programming language, we have 3 data types that are highlighted: short, int, long, among others. And the short can store the value in 2 bytes, and 26,445 represented in hexadecimal is 674D, 2 bytes. Integer, 4 bytes. And you can see the same value represented as hexadecimal. Long, 8 bytes, meaning that you're talking about 64 bits, and you can see the value represented as hexadecimal on the screen. So this basically means that the same value can actually be stored in 2 bytes, 4 bytes, or even 8 bytes, depending on the data type that you use. Now let's get to another concept: signed and unsigned concept as used with data types. So signed means that it has a sign, and it means that that data type can hold both negative and positive values, while unsigned means that there is no sign, and this means that all the values are positive from 0 going onwards. Now let's look at 2 data types in C programming language. We have the byte, which is unsigned, meaning that it takes 0 to 255 because it stores the data in 1 byte. And now you have S byte, which is signed and stores the data in 1 byte, but that means that we can store negative 128 to 127. This is because one of the bits, the leftmost bit or the most significant bit, is used as a signed bit. When it is set to 0, we assume it's positive. When it is set to 1, you assume it's negative. If 1 bit is taken away, then you're left with 7 bits. 2 to the power 7 is 127, and that's why you have the maximum positive value as 127. In case you're wondering how we got negative 128, you can check out 2's complement, which is what we use to represent negative numbers within computers, a concept that we'll tackle in a later episode. Now let's look at more data types. Java can represent number as either byte, short, int, or long. Now byte is 1 byte and it is signed. Short is 2 bytes and it is signed. Int is 4 bytes and it is signed, and long is 8 bytes and it is signed. Now the ranges are from negative to positive because they're signed. The possible values, as you know, you can take the number of bits and you take 2 to the power the number of bits. So in case you're dealing with an integer, it's 4 bytes, which is 32 bits, 4 times 8, and that gives us about 4 billion plus possible values. When you take the negative and the positive, you get the values on the screen. Of course, when you're dealing with 8, you're dealing with a huge number, quintillions, and this is enough to cater for most of the scenarios that have ever experienced. So Java does not have unsigned data type. This is something that you must remember when you are dealing with Java. And of course, I'm calling you to use the correct type. So in case you're representing data, you must use the right data types to avoid wastage of memory and storage. Allow me to move to another concept that is also quite relevant when you're dealing with data and represented in binary. It's the LSB and MSB. LSB means least significant bit, and MSB means most significant bit in data types. So if you look at a short XC701, when you represent it as 2 bytes, then it's 0B to B, BD, sorry, 0 to BD. Those are the nibbles or 4 bits symbols. And when you represent it as binary, you can see the number at the bottom here. Now, when you talk about significant, it's not a new concept. You probably learned it in your lower levels of education. In Kenya, when you're in primary school, you must have learned about 2 in this number, 2,345 being the most significant digit and 5 being the least significant digit. In the same way, when you're looking at the same bits as represented on the screen, the bit to the right is the least significant bit and the bit to the left is the most significant bit. Now, that allows us to move now to an exciting concept, Big Endian and Little Endian. Now, the question has been, given the series of ones and zeros, when you're sending over the network or even saving in memory, which bit do you start with? And there are people that have never agreed. We have 2 camps, and the first camp is called the Big Endian camp, and the other camp is called the Little Endian camp. And the Big Endian camp believes that you start with the big end, or you start with the most significant bit. So you send the data starting with 0 first, then the next 0 all the way to the last 0, starting from the left going to the right, meaning starting from the big end going to the small or the little end. Now, the Little Endian camp argue that you start with the value, the least significant value. Remember, the value was the last 4 digits. You can note it's 0011, meaning that you're starting from the least significant value, sending 1 bit at a time all the way to the most significant value. So this is basically a detail that is applied within the computer, and up to now, no winner has been declared. And as a developer, you don't need to worry about this so much. And I know you guys have not worried about it in the past. But is this knowledge useless? I beg to argue that it's not useless. And in a few seconds, you'll be able to see that. Now, why are we learning data types and why are we learning about Big and Little Endian? Now, the first thing is that when you learn about data types, you can do memory optimization. If you declare the age of a person, you can use 8-bit unsigned probably, or 8-bit, yes, to represent the age. And even if you use signed, which is -128 to 127, you probably have up to 127 years, which probably could cover majority of the people, if not all. If you declare that value as int, then you're going to use 4 bytes and you're going to waste 3 bytes storing the value, because all the 3 bytes will have the value set as zeros, and you'll basically be wasting the memory location. So I know this is something that you guys have not been worrying about, but when you're dealing with millions of records, e.g. in telco and bank applications, where you have maybe 40 million subscribers, if you're storing data in memory, saving 3 bytes could significantly save memory and make your application perform better. So these are details that you should not ignore. Another scenario is something that I really love. I know I've talked about being a telecoms engineer. Have you heard about SMPP? If you haven't, SMPP stands for Short Message Peer-to-Peer Protocol, and it is used in building SMS and USSD applications. Now, I'll introduce a bit of complexity, and I hope that you'll work with me. Now, when you're dealing with mobile telephony or mobile networks, and you're dealing with SMS and USSD service, a number of subsystems are involved. So you have your phone, which you call the mobile station or the MS. You have the network, or some people would call the base station subsystem. This is the radio network. The radio network connects to the switch, and the work of the switch is to switch calls and switch messages accordingly. Now, if you're sending an SMS, the message is forwarded to the SMSC by the switch. And for those of you who have done messaging, there is a system called Service Delivery Platform, which allows that parties to connect to the SMSC. Now, if you're dealing with USSD, so the switch determines that these are USSD message, and it can forward the message to the USSD gateway, depending on the configurations on the switch. And the USSD gateway can forward the message to something called the USSD browser. And some of you who build applications connect to the USSD browser. Now, one thing to note, in some telcos, the SDP does not exist. So you can connect to SMSC directly. And in some telcos, they also don't have a browser. So you, as a third party, you can connect to the USSD gateway. The other thing I want to mention is that the communication between the SMSC and the SDP, it's not a HTTP API, it's SMPP. And that's why we're here. Between the USSD browser and the SSD gateway, it's still SMPP. Now, if you're building your application, your USSD app, you can either connect to the USSD browser, or you can connect to the SSD gateway directly. If you're building an SMS app, you can connect to the SMSC directly, or you can connect to the SDP directly. And this is dependent on the telco. Now, if you are connecting to the USSD browser, which most of you do, when you're building your SMS USSD applications, you use a HTTP API. But if you go to a telco that doesn't have the HTTP API, they'll probably tell you to connect via SMPP. If you're building your SMS app, most of you have already done so. You connect through SMPP API. And if you're using SDP, most SDPs support HTTP, and others have capability to also connect via SMPP. So basically, I've just introduced a new protocol, which is used in messaging, both the SSD and SMS messaging, and I've described where it is applied. Now, in the event you choose to become a telco or a telecoms engineer like me, you'll have to develop in SMPP. And if you read the SMPP specification, and I'm reading 3.4 and even 5.0, which is the latest version, has the same spec. So you'll see that the SMPP protocol data unit type definitions, the data types used by the protocol, they have integer, which is unsigned value. You can see unsigned value that is defined with a defined number of octets. The octets will always be transmitted MSB first, or big endian. So you have seen MSB and big endian in use. You've also seen unsigned value in use. And this is not Greek anymore. So basically what I am trying to do is to prepare you to read these specifications and write code that conforms to this specification. And that brings me to the end of this episode. If you found the concepts interesting to you, or you think they could be beneficial to someone else, please share and feel free to like, comment, and subscribe. Thank you very much, and see you again in the next episode.